All right, last page. So do the data in the table below appear to come from a normal distribution? Explain your reasoning. A couple of different ways to attack this. We could look at the, histogram and see if it's approximately mound-shaped and symmetric. And you go, no, that's dramatically right-skewed. This is definitely not mound-shaped and symmetric. So this is a highly right-skewed distribution. So I could argue that that would say that it's not normal. Or I could look at the normal probability plot. So there's my data, zoom 9. This should come out to be linear, and it's clearly non-linear. It's got this dramatic bend into it. So therefore, you would say, no, it's a highly right-skewed distribution. Or we could say the normal probability plot is clearly nonlinear. Therefore, data is not normal. Your sample contains 50 observations from a distinctly non-normal distribution. The population distribution has a mean of 100 with a standard deviation of 15. Can you find the probability that your sample mean is less than 95? If so, find this probability. If not, explain why you cannot. Well, what did they tell us? Our sample size is 50. Remember, if n is greater than or equal to 30, then the central limit theorem assures the normality of the sampling distribution. So therefore, we can actually do this problem. Now, if this had been, like 10 observations, then the answer would have been no, we couldn't do it because we wouldn't be able to rely on the normal distribution because the sample size is too small, and this is definitely a non-normal distribution. So if the distribution of the parent population is non-normal, then our sample size needs to be larger than 30. So the answer here is yes, so find the probability. So we're going to do our z-score is what we observed, so less than 95, so I'm going to have 95 minus 100 divided by 15 over the square root of 50. So we're doing this. 95 is down here. We want to be less than, so we're doing this area. So let's see, what's our z-score? Quit out of here. So we'll go 95 minus 100 divided by 15 over root 50. And so I've got negative 5 divided by that previous answer. So this is negative 2.35. So we're going to do normal CDF from negative infinity up to that negative 2.357. Should be pretty small. I get 0.009. So the probability that our value, or our average, is less than or equal to 95 is approximately 0.009. You bought a widget for $1,000. You estimate the probability of the widget failing and needing to be replaced in the next 2 years is 10%. So the probability of failure is 10%. So that means no failure is 90%. Manufacturer offers a warranty for $150. Should you buy the warranty? Use expected value in your argument for or against buying the warranty. Well, what's going to happen to us financially if we buy this warranty, right? So if we buy the warranty, we're going to be out $150, but we only really lose that money if the thing doesn't fail, right? So the probability that we actually lose that $150 is 90%. But if the thing does fail, then we're going to gain this $1,000, but it did cost us $150 to get there. So that means we're really just going to gain $850. And that has a 10% chance of making that. All right, so use expected value. So just need to find these are the only two things that can happen. We either lose $150 or we gain $850 with a 90% and 10% chance. So let's multiply these probabilities together. So 10% times 850 is $85. 90% times negative 150, so 0.9 times negative 150, that's negative 135. So we add those together, it comes out negative. So negative 135 plus 85 is negative 50. So should we buy the warranty? The answer is no, because we lose $50 on average in the long run. So therefore, no. The expected value is negative. So we lose money in the long run. The 5-number summary for a set of scores is this. Are there any outliers in the distribution of test scores? Show your work in making this determination. So we just need to figure out if this 5-number summary represents any outliers. Well, remember, the formula for outliers, we're going to take Q1 and we're going to subtract 1.5 times the IQR. And that's going to build us a fence in here. And if this value is smaller than this minimum, that means the minimum's not an outlier. And then we'll do the same thing, Q3 plus 1.5 times the IQR. And then we're going to build that fence out to the right. And if that's past 100, then 100's not an outlier. So let's figure out what the IQR is. So there's the interquartile range is 4. So the IQR is equal to 4. So 1.5 times the IQR is equal to 1.5 times 4, which is 6. So I'm going to take the first quartile and subtract 6 from it. So I'm going to go 80 minus 6 is equal to 74. So anything that's past 74 is an outlier. So 50 is an outlier. And then I'll do the same thing at the top end. So 84, so I'm going to go 84 plus 6. That gives me up to 90. So anything beyond 90 is an outlier. So that means 100 is an outlier. Now, if the question said, how many outliers are there? Well, we don't know, because we don't know how big this distribution is. Because this 50 is just the minimum score. We don't know how many 50s there are. We don't know if there's any 51s or 52s. Same thing up here. 100 is the maximum score, but how many scores are there above 90? We don't know. So therefore, we don't know how many outliers there are. We just know that some exist. There's at least 2, one at the top and one at the bottom for this particular distribution of scores.